Good day, everyone. I'm Ivan Claire Mendoza from BSECE 3B, and now I will present my performance number 5 in ECE 23 entitled Gaussian Minimum Shift Keying. What is GMSK modulation or Gaussian Minimum Shift Keying? Gaussian minimum shift keying or GMSK is a form of modulation based on frequency shift keying that has no phase discontinuities and provides efficient use of spectrum as well as enabling high efficiency radio power amplifiers. GMSK modulation is based on MSK or minimum shift keying, which is itself a form of continuous phase shift keying or CPFSK. One of the problems with standard forms of PSK is that sidebands extend out from the carrier. To overcome this, MSK and its derivative GMSK can be used. MSK and also GMSK modulation are what is known as continuous phase scheme. Here are no phase discontinuities because the frequency changes occur at the zero cross points. This arises as a result of the unique factor of MSK, that the frequency difference between the logical 1 and the logical 0 states is always equal to the half data rate. This can be expressed in terms of the modulation index, and it is equal to 0.5. A plot of the spectrum of an MSK signal shows sidebands extending well beyond a bandwidth equal to the data rate. This can be reduced by passing the modulating signal through a low-pass filter prior to applying it to the carrier. The requirements for the filter are that it should have a sharp cutoff, narrow bandwidth, and its impulse response should show no overshoot. The ideal filter is known as Gaussian filter, which has a Gaussian shape response to an impulse and no ringing. In this way, the basic MSK signal is converted to GMSK modulation. One of the advantages of MSK modulation in general and in this specific case, GMSK is that the MSK modulation makes the phase change linear and limited to positive negative pi over 2 over a bit interval t. This enables MSK to provide a significant improvement over QPSK because of the effect of the linear phase change. The power spectral density has a low side lobes that help to control adjacent channel interference. However, the main lobe becomes wider than the quadrature shift keying. There are two main ways in which GMSK modulation can be generated. The most obvious way is to filter the modulating signal using Gaussian filter and then apply it to a frequency modulator where the modulation index is set to 0.5. This method is very simple and straightforward, but it has a drawback that the modulation index must exactly equal to 0.5. In practice, this analog method is not suitable because component tolerances drift and cannot be set exactly. A second method is more widely used. Here, what is known as a quadrature modulator is used. The term quadrature means that the phase of a signal is in quadrature or 90 degrees to another one. The quadrature modulator uses one signal that is said to be in phase and another that is in quadrature to this. In view of these in-phase and quadrature elements, this type of modulator is often said to be an IQ modulator. Using this type of modulator, the modulation index can be maintained at exactly 0.5 without the need for any settings or adjustments. This makes it much easier to use and capable of providing the required level of performance without the need for adjustments. For demodulation, the technique can be used in reverse. So we have here the advantages of GMSK modulation. It improves spectral efficiency when compared to other phase shift keyed modes. It can be amplified by non-linear amplifier and remain undistorted. This is because there are no more elements of the signal that are carried as amplitude variations. This advantage is of particular importance when using small portable transmitters, such as those required by cellular technology. Nonlinear amplifiers are more efficient in terms of the DC power input from the power rails that they convert into radio frequency signal. This means that the power consumption for a given output is much less, and this results in lower levels of battery consumption, a very important factor for cell phones. The information is carried as amplitude variations. This means that it is immune to amplitude variations and therefore more resilient to noise than the other forms of modulation, because most noise is mainly amplitude based. Gaussian minimum shift keying proved to be a particularly successful from the form of modulation for GSM and some other radio communication systems. Its combination of spectral efficiency and capability to enable efficient power amplifier operation enabled it to be an excellent choice for radio communication systems of the time. So that would be all. Thank you and keep safe.